Hi, I'm Doug Bentley, Head of Product Development for Klarius Group. I'm here today to talk to Frank Massey from ADS about diesel particulate filters. I'm going to give a quick summary today of what they are, why they're required, and then Frank's going to talk through some of the technical details about diagnosis and why we'd replace them. So for a look at the diesel particulate filter, this is one fresh off the shelf at our place. We'll take it apart and see what's inside. It's a new unit we're going to supply for this vehicle. It's actually a combined catalyst and DPF all in one unit. And this is for the Peugeot 307 we've got here ready to have a look at. Inside we've got the fitting instructions, the warranty, all of the relevant mountings and fittings we need to do the job correctly. And of course, very important, the type approval certificate to prove that we've tested this product for this application. In terms of construction, here we go. The unit's a one-piece item. As I said before, it's got the catalyst in the front and the DPF filter in the back. Now, importantly, on some vehicles, these are actually split. The catalyst is always in front of the filter, but sometimes the filter is separated and the filter can just be replaced on its own. Additionally to that, we've got some simple mounting points for the rubbers and the inlet and outlet ports here, and we've covered those up for transport, and some sensor ports here for temperature as well as pressure. But Frank, do you want to go through a little bit of detail about diagnosis and why from a technician's point of view we need to replace it?
Right. First consideration is, before we talk about why DPFs go wrong, let's talk about the cause. The blocked DPF often is, in reality, the symptom, not the cause. If the DPF filter has become contaminated or blocked or restricted in any way, then effectively what's in there is soot that has not been burned off during the combustion process. For soot to be successfully burned off, you're looking at temperatures passively of above 300, 350 degrees. In other words, that by natural driving technique, those soot particles can actually be burnt off without any regeneration process being requested. If the pressure in the DPF becomes excessive, we'll come back to some of these issues in a moment, then the vehicle will then go into the next phase of regeneration, which is active regeneration, where the vehicle will request certain physical changes to the fueling of the engine. And the key responsibility here is to raise the combustion temperature so that the exhaust gases temperature also raises, and then that raise of temperature then will burn off the soot particles which are contained on the DPF filter. So that's roughly the process that takes place. Why do they go wrong? Well, actually it can be a complex set of reasons, some of which the driver has actually no control over. Choice of fuel is a big one. Choice of lubricants and the correct servicing interval is also a big issue. Driving technique. Now, I'm not for 1 minute blaming the driver for driving the vehicle incorrectly, but quite often the environment that the vehicle is operated in is not conducive to correct DPF treatment. When do we change it? Right. When the blockage becomes excessive. Now, all right, we'll talk about what sort of pressures become considered excessive. When the blockage becomes excessive, you have really only two choices: to clean it or replace it, and that's it. You cannot and must not go through the attempt of a regeneration process with a severely blocked DPF. The results can be catastrophic. In fact, in many cases, the actual electronics won't allow that process to take place. They'll restrict you from doing what is the third stage, which is actually a forced regeneration process, where you actively request a regeneration through a software platform. So those are some of the basic reasons why and when.
And is cleaning cost effective, or should we just go ahead and replace? And are there any other issues about replacement, like fixing faults on the car at the same time?
Absolutely. Never replace the DPF without fixing the cause in the first place. So if you have a badly blocked DPF, at least counsel the customer, ask some questions about the type of use, the servicing regime, things like injectors, EGR valves. These are all related components that cause this problem. It would be inadvisable to put an investment in a new DPF and catalyst without at least considering some of the causes. New or clean, I think you can never discount the fact the best choice is always a replacement. Given mileage, high mileage, because obviously the catalyst will age as well. That's a consideration. I would hope we're all conscious of the environment we all live in, and for these to operate effectively will protect that environment. So it's a lifestyle thing for all of us.
And is cleaning even possible on these combined units? Obviously we can't get at the face of the brick with this enclosed unit to clean it.
Exactly. There's in fact a limitation purely by decision and choice, that you can imagine if you're going to force some kind of cleaning agent through this component, that because of the construction, and we'll have a look at one of the DPF elements shortly, by the construction alone, you're not going to get a very effective cleaning process. So cleaning is always a second choice.
Okay. And of course, we'd always recommend replacement and fitting a new unit with the correct diagnosis of the vehicle as well.
Sure, yes. And it's important also that having replaced the unit, that quite often, if there's a DTC indicating a blockage, even though this is a new unit, you have to go through a regeneration process to clear all the defaults down in the ECU. And there's also things like readaptation procedures as well, but we can go into that a little bit later on.
So what happens if we fitted a new unit and just didn't do any diagnosis of what went wrong? Can the fault reoccur? How long will it take to clog?
It's likely the fault will come back more or less straight away, because things like readaptation, of resetting the DTCs, not going through a regeneration process, all will be stored in the PCM. So basically the car still won't fuel correctly.
And what's the sort of interval of regeneration? So how quickly would it clog if you didn't replace it?
With a serious fueling defect, probably within the first several months rather than years.
Yeah.
Definitely.
And what would the user notice, the first stage of something going wrong?
Lack of power. I think any blockage in the exhaust exit route, immediately, lack of power, you'll lose turbo boost, things like the air mass meter. Because you've got a decrease in the volumetric efficiency of the engine, all the aspects, breathing of the engine, drawing in air, compressing it with the turbo, pushing it out through the exhaust, is all compromised.
And then the next stage, would it go into limp home mode then?
Into limp home, reduced power, turns the fueling down, turns boost off. Basically a car that effectively becomes a non-turbo.
So that's the right stage then to take it to the technician to have a look at it.
Yes.
What happens if the user carries on blindly and keeps using this?
Eventually it'll block so badly that the car will become almost unusable. There can be other, in a moment we'll take a look at one that has failed severely, potentially where it can lead if you carry on driving. So from an end user's perspective, we hear a lot about cheap replacement products, possibly reduced size. I mean, as an end user, what implications does that have?
Well, at Klarius, we always take a very stringent approach of designing the replacement component to work in a similar manner to the original. And as you can see from what you said on diagnosis and the faults that can go wrong, that's really important. So we'll take a look at what's inside. So here's the sort of unit there. If you look actually in the front end, there's a diesel oxidization catalyst. And this is as per normal. They've been in vehicles for the last 15 or 20 years. What's different about the DPF is in the back half there's a filter, and this is around between 6 and 12 inches long depending on the application, and actually as the particulate matter comes through the device, it's trapped in the filter and contained and stored, and then during regeneration it's periodically burnt away. But over time, because this is a service item, remember, although the particulate matter is disposed of, a little bit of ash always remains, and that builds up over time and means there is an actual duration that this product will last for. But of course, if you start to cut corners on the design, the most obvious one we see in some of our cheap competitor products is that the brick length is shortened quite dramatically, and of course this affects capacity. And as you well know, Frank, the capacity then affects the regeneration interval, if you'd like to expand on that.
I've heard some comments about coatings as well. What importance do coatings have?
Well, the coatings are there, of course, to help clean up the emissions, and it's predominantly platinum that's used, or platinum group metals on these, and you can see we've coated the DOC with platinum. But importantly, in some of the new applications, we're also having to coat the DPF brick with these precious metals to assist in regeneration. And then some of the later Euro 5 vehicles from 2009 onwards, the manufacturers, the OEMs, have done the whole job of the catalyst and the DPF just on the DPF brick. So they become quite heavily coated, and we're working on that technology now.
So are you saying then that the later units use one brick that serves both as a catalyst, a traditional catalyst, and the DPF?
The catalyst and just having a single DPF brick with a precious metal loading on there to do both jobs, the emissions reduction as well as capturing and disposing of the particulate matter.
Okay, right. So basically, once again, it's down to quality.
Exactly.
Yeah. A little bit about diagnosis, and I did mention briefly earlier what starts to go wrong. The first indication, quite often, this is a pressure differential sensor, and basically we measure pressure on the entry and the exit of the DPF, and if that differential becomes excessive, then it will go into one of two stages of regeneration. Well, it will go into a stage of regeneration. You have passive regeneration, where the vehicle's been driven normally. Active regeneration is when it sees an excessive pressure from this component. The ECU then looks at that pressure differential and brings into play a set of corrections, if you like. Those corrections, generally speaking, are the introduction of the use of the heater plugs, so they'll engage the heater plugs to up the intake air temperature. They'll change the fueling slightly, so there's fuel added to the exhaust stream to once again raise temperature. They boost the turbo, and the reason they increase turbo pressure slightly is to minimize the power loss which will be experienced during the regeneration process. And of course they use the induction. They turn EGR off. You don't want EGR recirculating when regeneration is taking place. So basically you're then going to raise the exit temperature of the gases, which are normally between 150 and say 300 degrees during normal driving, to around say 600, 650 during the regeneration process. And it's that increase in temperature then will burn that soot off that DPF. So the first symptoms are potentially a faulty signal from this component. This is, as I say, a pressure differential sensor. There are two connections to this component. There are some atmospheric pressure sensors where they use one pipe only, and I'm going to show you a catalyst in a moment, catalyst and DPF in a moment, that has that one pipe principle. That is purely a pressure sensor. This is differential. So that's one of the things that will give rise to a DTC or a fault code. What's important is all of those components I previously mentioned, EGR, heater plugs, etc., pressure differential sensor, all have to be within specification and working normally. No DTCs present. Any of those considerations and you'll not get regeneration. And drive opportunity is the biggest issue. If you're operating your car in slow-moving traffic over a regular period of time, I'm sorry to tell you, but your DPF is going to give you trouble. Therefore, there are things you can do. You can seek your local garage supplier, technician, and get them to do a forced regeneration process at regular intervals to maintain the quality and performance of the DPF. This is something that's done through a software tool, because you're not going to achieve that process during normal driving.
What about driving style? Is there anything the user can do to promote the like of this?
Yes, there is. I mean, by prolonged driving in open roads, I'm not suggesting speeding, but certainly driving smoothly at moderate speeds on the open road. Motorway is ideal. Then the regeneration process will take place naturally without the knowledge of the driver. Regrettably, and it's a pity that the driver doesn't have some kind of indication that regeneration takes place, because they could actively then promote it. Yeah. The driver is effectively blind to this point.
But even if the DPF is well looked after, the user does the correct sort of driving style, there is a finished life of this product. And what's that normally, Frank?
I would say 800,000 miles. It does depend on usage. We've seen failures on these devices at premature mileage of 40, 50,000 miles. We've also seen equally perfectly serviceable items at 100,000 miles plus. It is such a flexible situation. I say quality oil, lubrication oils, low ash oils, very important. Okay. Once again, all boils down to quality, good advice from your servicing supplier, good quality oil, good quality fuel, and the appropriate driving. Okay. And you should get a respectable life from the DPF. Okay. When things go wrong, this is once again, it's a combined catalyst and DPF. Obviously the entry is at this end, the exit is at this end. Single pressure measurement connection, so that's an atmospheric pressure sensor. The lambda sensor, which monitors oxygen content, will go in that aperture. This particular catalyst and DPF has suffered catastrophic thermal failure. This, we know some of the history of this because it was a repair that we'd concluded ourselves. This particular DPF, the catalyst is here, DPF is here, two separate bricks, had become severely blocked. We know that the pressure initially was excessive, and an attempt was made for a 4.3 generation with an excessively blocked DPF. And all we can assume from this is that the excessive soot did ignite, and this damage has been caused by the combustion temperature inside that casing, and it's melted a stainless casing.
It's got to a really high temperature, hasn't it?
1200 degrees or so, I would say, at a guess.
That's sort of double the expected regeneration temperature.
Yes, we have heard of many cases where this type of failure has actually caused the car to burst into flames. We also do know many manufacturers, and Mercedes is one of them, that have actually removed 4.3 generation from their platform, their in-house platform, to prevent technicians from even attempting this. So the manufacturers are becoming very aware now of the potential dangers of this. And of course their point of view then is replacement.
Yeah. But it's a technology that's here to stay. I mean, they've been on vehicles from probably around 2000, 2001, but from Euro 5, that's 2009,
Yes.
all new diesel cars had to have them fitted, of course, and that's about 50% of the cars on the road today.
Yeah.
So
Yeah.
this technology is here to stay, and from a technician, a garage's point of view, we need to learn about them, educate, and of course, from a manufacturer's point of view, have the range available for sale.
Yeah, I think it's also an opportunity for the independent garage, in fact, any repair facility, to start educating their end user as to how to avoid this. And in doing so, it may necessitate additional service action on the vehicle.